Chapter 1, Section 4, Angles and their measures. An angle consists of two different rays that have the same initial point. The rays are the sides of the angle, and the initial point is the vertex of the angle. So here I have ray AB, where A is the initial point and B is a point on the ray. I'm going to also add another ray, ray AC. A is the initial point of ray AC also. Notice I have two rays with the same initial point and they have created an angle. The initial point is called the vertex of the angle, and the two rays are called the sides of the angle. When we notate an angle, we can do so in three different ways. We can call this angle CAB or angle BAC. I've used the 3 points from the angle, one on each side, and then the vertex. If you notice that in both, the vertex A is in the middle. That is important. The points from the sides, the order does not matter. The vertex always has to be the point in the middle of your notation. Because there is only one angle, we could also write it angle A, only using the vertex. That's okay when you're talking about one angle, but in a minute I'm going to show you an example where you cannot just use the vertex because it wouldn't give you the information you needed. So better safe than sorry, name it with 3 points from the angle. Naming angles example. This asks us to name the angles in the figure. The first angle I'm going to start with is the acute angle, right here. I can name this with N in the middle because N is the vertex. M and P would be points on the sides of the angle. So I can name it angle MNP or angle PNM. It does not matter which one you use as long as the vertex is in the middle and your 2 points from the sides are on either side of the vertex. The next angle is the obtuse angle. Again, N is the vertex. P and O would be points on the sides. So I could name this angle PNO or angle ONP. The third angle that might not stick out as much as the other two would be the straight line angle or a straight angle. Again, because N is in the middle, it is the vertex. We have opposite rays. The points on the rays are M and O. So in this case, I can name it angle MNO or angle ONM. Why would just naming it angle N not work? Well, if you notice, there are actually 3 angles with N as the vertex. So if you just said angle N, I wouldn't know which 3 of the angles you were talking about. In this case, we need to be more specific and name it with 3 points. Angle PNO and angle MNP are called adjacent angles because they share a side. If you look at the 2 highlighted angles, you'll notice that they share the ray NP. Angles that have the same measure are called congruent angles. In the last lesson, we talked about congruent segments. This means the same thing. They're just angles that have the same measure, so we can call them congruent angles. When we're talking about the interior and the exterior of angles, the interior is the space in between your 2 sides, and the exterior is the space on the outside of the 2 sides. Here I've labeled the interior and the exterior of this angle. The angle addition postulate, it's fairly similar to the segment addition postulate, but now we're talking about angles. It states that if P is on the interior of angle RST, which is represented in the picture below, then, and the little m stands for measure, so then the measure of angle RSP, right here, plus the measure of angle PST, the other small angle, equals the measure of angle RST, the whole angle, this orange part. An example of the angle addition postulate says that in the figure above, the measure of angle CDE is 62 degrees, and the measure of angle EDF is 18 degrees. It asks us to find the measure of angle CDF. First thing I need to do is label on the picture what they tell me below. So angle CDE is 62 degrees. Go ahead and label it. And angle EDF is 18 degrees. Go ahead and label it. Now it should be pretty obvious we're talking about angle CDF, the larger angle. We can use the angle addition postulate. Your two smaller angles, or the two angles on the interior of the larger angle, so 62 degrees plus 18 degrees equals the whole angle CDF, which is 80 degrees. When we classify angles, we can classify them as acute, which measures less than 90 degrees, right, which measures exactly 90 degrees, obtuse, which measures between 90 and 180 degrees, and a straight angle, which measures 180 degrees. A straight angle is simply a line. The next example asks us to draw 5 points, A, B, C, D, and E, so that all 4 statements are true. The 4 statements are angle AEC and angle BEC are adjacent, angle AEB is obtuse, D is in the exterior of angle AEB, and angle DEC is a right angle. If you come across a problem like this, know that it's okay to start with points and know that you're probably going to have to erase and move points as you start looking at different statements to make true. The first statements that I want to look at are actually the first 2. The first statement, angle AEC and angle BEC are adjacent, tells me that these 2 angles are going to share a side or a ray. If you notice, they have 2 of the same points. So E and C need to be points on the ray that these 2 angles share. E is the vertex because E is the middle point in these notations. The second one says that angle AEB is obtuse. So I'm going to start with my points, and I'm going to start with A, E, B, and C. And I'm going to go ahead and make E the vertex. If you notice in this picture, and your picture does not have to look exactly like mine, it can look different, but it does have to satisfy all 4 statements. So if you notice, angle AEC and angle BEC are adjacent. That is true because they are sharing ray EC. The next one says that angle AEB is obtuse. Obtuse means greater than 90. If you look at the larger angle AEB, it is obtuse. The next one says that D is in the exterior of angle AEB. So I need point D to be on the exterior of the largest angle AEB. It also says that angle DEC is a right angle. So I'm going to put point D here, and we notate a right angle using a square at the vertex. So if you notice, D is on the exterior of angle AEB, and D is also a right angle DEC is also a right angle. Again, you're probably going to have to just put points down and move them as you start looking at different statements, but always go back and check to make sure that all of the statements are true. The next example is number 41 from your book. It says, plot the points and draw angle ABC. Classify the angle and give one interior point and one exterior point. I'm going to plot point A at 5, -1, point B at 3, -2, and point C at 4, -4. When you've plotted these 3 points and you go to make an angle, there are actually 3 different angles that would be possible to make. It is important that you look back at the notation in your directions. It says plot the points and draw angle ABC. We're thinking back to what we've already learned, and we know that B, because it is in the middle of the notation, has to be the vertex. There is only one way to draw an angle using these 3 points where B is the vertex. So my angle should look like this. Notice 2 rays with the initial point of B. So A and C are on the sides. Now, there are several different interior and exterior points that you could give me. I'm going to show you 2. If you choose 2 that are different, that's okay. They could still be correct, but make sure that you understand why my points are interior and exterior. The interior point I'm going to choose is 5, -3. Notice this point is on the inside of the 2 rays, or between the 2 rays. The next point, the exterior point that I chose, is 0, 0. Notice that it is not in between the 2 rays. A review asks us to solve for x. We have x plus 3 divided by 2 equals 3. When we're trying to solve for x, our goal is to get x by itself. The first thing that we need to do is get rid of the divided by 2. The opposite of dividing by 2 is multiplying by 2. Remember, whatever you do to one side, you have to do to the other. So here, I'm going to multiply by 2 on both sides. These 2's cross each other out. Multiplying by 2 and dividing by 2 are undoing each other, so we can just get rid of it. I'm left with x plus 3 equals 6. 3 times 2 is 6. Now to solve for x, all you need to do is subtract 3 on both sides, and you get x equals 3. Remember, you can always go back and check your answer. So I could go back and plug in 3 for x. Well, 3 plus 3 is 6. 6 divided by 2 is 3, and that solves the equation. Today's assignment is on page 29, numbers 17 through 22, 26 through 42 even, 44 through 49 all, and 62 through 78 even.